right, so Math 335, day 22. We are prepping for 13.4, which is on nonlinear systems. .5 on linear inequalities. And I try to prep you for 13.6 systems of inequalities, which kind of does 13.4 and 13.5 together. And I really think the only real way we're gonna do something effective with you guys is just to jump right into a problem. There's no real explaining what's going on without just doing it. So let's say x squared plus y squared equals 9. And we're gonna do y plus x equals 3. 2. Let's go with 2. So one of these is a circle of radius 3, centered at the origin. And this one, if I solve for y, is negative x plus 2, which starts at 0, 2, and has a slope of negative 1, so it goes downward. So the line is there. And the circle is this. They clearly intersect. They intersect right here, and they intersect right here. And it looks like 3, 0 and negative 2, 1. But we're not going off my graph, because we've already seen how bad my graphs can be. We're gonna actually just solve this algebraically. So these were the equations we started with. Just like we did with systems of equations with 2 variables, and they were both lines. One of the methods we had was substitution, and we also had that addition elimination method. Substitution works really well here. By solving for y, I can take this and plug this in for y up here, and I get x squared plus negative x plus 2 squared equals 9. So I just replace y with negative x plus 2. And use parentheses, because the square needs to hit the whole thing. Remember, when we square that, that is going to be negative x plus 2 times negative x plus 2. So that is going to give us, this x squared is the same. And when we multiply this out, we get plus x squared minus a 2x and minus another 2x is minus 4x plus 4 equals 9. We'll bring the right side down. Everyone with me? I'm gonna subtract the 9 over, and I'm gonna group together the x's, and I got 2x squared minus 4x minus 5 equals 0. And I don't think that factors, which means these are probably wrong. We'll do the quadratic formula. X equals negative b, which is positive 4, plus or minus the square root of b squared, negative 4 squared, minus 4 times a times c is negative 5. All over 2a is 2 times 2. So that's 4 plus or minus 2 times 5 is 10 times 4 is 40, and we're adding it. 40 plus 16 is 56. It's 56 on the inside. All over 4. Which means that is definitely not 3, 0. Because I don't have a perfect radical. So I could factor out a 4. 56 is 4 times 14. So I could say x equals 4 over 4 plus or minus 2 over 4 square root of 14, which is 1 plus or minus square root of 14 over 2. That's the x coordinates. We need the y coordinates. So probably just plug them in the line. Y equals negative x plus 2, negative 1 plus or minus square root of 14 over 2. So the positive route, and then I have a plus 2 outside. The positive route is negative 1 minus the square root of 14 over 2 plus 2. So that's 1 minus square root of 14 over 2. And if I take the negative route, I think the radical just has a different sign. So we have 2 points. 1 plus square root of 14 over 2. And that goes with 1 minus square root of 14 over 2. And the second point is just the other way around. Just happen to be coincidence here. Does that make sense? We can check. Let's check our points real quick. So we got those 2 points. So we'll check them in x squared plus y squared equals 9. And we'll check them in y plus x equals 2. So I have 1 plus root 14 squared plus 1 minus root 14 squared. That's going to work for both equations. When either point is going to give me the same thing for this one. So we can check both points at the same time on this circle. This is 1 plus let's see, if I'm distributing. I've got 14/2 and 14/2 is just a root 14. And then I have, multiplying these together, I have plus 14/4. That's the first parentheses. This parentheses, if I do the same thing, has a minus sign here. I'm gonna have 1 minus root 14. Plus 14/4. And so does that equal 9? The root 14s cancel. I add up the ones, I got 1 plus 1 is 2. And 14/4 plus 14/4 is 28/4. That's 2 plus 7, and that does equal 9. And checking the other equation is gonna kind of check them at the same time too, since they're opposites like that. You got 1 plus root 14/2 plus 1 minus root 14/2. Does that equal 2? It doesn't matter if I put it in for y or x, the other one just has the opposite sign on the radical. I add them together, 2 does equal 2. So I worked on both equations. So it's kind of similar to what we were doing with the systems of equations, but they're not both lines anymore, or straight lines. Any questions? Okay, so that's kind of like what we're going to be doing in 13.4. Let's take a peek at what we're going to be doing in 13.5. So inequalities are in 13.5. Let's say I have y equals 2x minus 3. Or y is greater than or equal to 2x minus 3. And we'll also look at doing y is less than, let's see, negative 2x plus 1. Okay, so when we graph these, and the solution, really the only real way to find the solution is like graphically. So what we do is graph them like lines. If we have an inequality like this or like this, use a straight line. Solid line, I should say. If we have an inequality like this, use a dashed or dotted line. So See if I can do this any justice right here. Well, that didn't come out very straight, did it? Let's straighten that out. So I'm gonna do this one first. Graph it like it's a regular line, so y equals 2x minus 3. We have a y-intercept of 0, -3. And I have a slope of 2, or 2/1. So I'll go up 2/1, up 2/1, up 2/1, up 2/1. Now you can never go wrong just starting with the dash. Just to make sure. But this one does have an equal sign, so I don't need a dash. I'm gonna fill in the gaps in the dash line. I'm gonna just make it solid. Solid line means the line is included in the solution. It meets the inequality. The dash line says the line is not in the solution. Throw that green inside. Okay, so after that, what we do is, I'm gonna write on the next page, the rules, but I'm gonna do it on the graph on this page. So that was step one. Step one is graph the line. Step two. Test a point not on the line. To see if it makes a true statement. If it does, shade in on that side of the line. If it doesn't, shade the other side. Okay, so a great test point, the perfect test point, if it's not on the line, is 0, 0. Because when you plug in 0, doesn't matter if it's squared, it doesn't matter if it's multiplied by anything, that just the whole term becomes 0. So it makes it really easy to test. So I'm going to test 0, 0 right here. Is 0, which is right here, of course, 0, 0 is right there, is 0 less than or equal to 2 times 0 minus 3. So is 0, or not, sorry, less than, is 0 greater than or equal to negative 3? Yes. So what I'm going to do is 0, 0 is on this side of the line. I'm going to shade over here. And that's just a convenient way of shading it. So any point on this side works. I could use 0, 10. I could use negative 20, 0. Any point is going to work. You just need to pick one and test them. So the answer is all of these points. Everything on the upside of this line works. All right, let's do the same thing for this one. Let me bring back down. This. Y is less than negative 2x plus 1. It has a y-intercept of 0, 1, and it has a slope of negative 2. So we'll do it as negative 2 over 1. I have that. I have that. That. And now, since it's strictly less than, we're going to use a dashed line. This tells us that that line is not part of the solution. So I'm graphing them separately. I'm treating them as two different lines because these are two different problems. In 13.5, they're going to be two different problems. I'm just happen to do them on the same graph because it'll show you how 13.6 works at the same time. Zero, 0 is not on the line, and I can check it real quick to make sure it's not. If I plug in 0, I have 0 less than negative 2 times 0 plus 1 is 0 less than 1. So if 0, 0 was on the line, this would be 0 equals 0. We would get the same numbers on each side. As it is, this ends up being a true statement. So we're going to shade on the side of the line that has 0, 0, which is here. So I'm going to shade here. Does that make sense? So if it was the red one, it would be all of this. If it was the blue line, we were doing all of this. For a system of inequalities, if this were a system of inequalities, we use the overlap of the shaded regions. And fill or solid lines.
The projector can go lower, or is it,
What now?
this thing was working? How do you?
Oh, shit. Sorry, thank you. Didn't know. Okay, so if this were a system of inequalities, the system would be this region. The green region would be our solution. So the green region in graph above is our solution. Or would be the solution. It's got some of each. It does not include the blue line, but it does include the red line that's below that boundary. Does that make sense? So it has to be both regions at once. You guys want to try one? I'll give you two. In fact, let's try the system of inequalities. That way you graph them separately, but do them on the same graph. And then look for the region of overlap. And we'll keep it nice and simple. We'll just stick with lines for now. Let's do y equals 3x minus, I'm sorry. Y is less than or equal to 3x minus 1. And then we'll do y is, let's see. Let's say 3x plus 1. And we'll say y is greater than. See, that's like that. Nope, that's like that. Let's go less than negative 2x plus 4. Y is minus 4, negative 2x minus 4. Well done, Sarah. Not too bad. Roberto, how you doing? Still working on it? Okay, keep going. You get it, Roberta? Okay. Let's see what we got. So 3x plus 1. We have a y-intercept of 0, 1. A slope of 3/1. So rise 3/1. Rise 3/1. It has an equal portion, so I'm going to make it a solid line. If I plug in 0, 0, I have 0 is less than or equal to 0 plus 1. 0 is less than or equal to 1, yes. So 0, 0 is right here. So I'm going to shade on the side that has that. So just shade down. Everything over there. If I graph this one, negative 2x minus 4, 1, 2, 3, 4. And m equals negative 2/1. So I can either go down 2/1 that way, or I can go up 2/1 this way. And since it's got no equal sign, we're gonna just do dashes. And so, and if I plug in 0, 0, 0 is greater than 0 minus 4. 0 is greater than a negative number. So we're shading on the side of 0, 0, which is that direction. So, as a system of inequalities, this is a great time for that green one. A system is going to be where they overlap. Both red and blue are in this region. Is that how you guys got? What you guys got? Alberto, you something close to that? Okay, so if you want it less messy, because this is kind of messy, right? What we can do to make it less messy is, I'm not going to put in the hash lines, but I'm just going to illustrate how to do it. We had like that right there. And we have something like that, right? Oh, this is dashed. I think this is a dashed line. So one way of doing it is, rather than shading the whole thing like that, just put like a plus sign on the right side, a couple plus signs. So it doesn't take up a whole lot of room. And then do the same thing for the red one. Couple plus signs throughout it. And now you're looking for the region that has both colored plus lines. Or plus signs from both ones. Or maybe if you're using the same like pen, and it's the same color. Maybe do the plus ones with circles on them. That way you can distinguish from them better. So you're looking for the region that has both symbols that you put down. You could also do something like A and B, so those are like used letters. But once you have that, then shade. And now there's not shading everywhere. How's that work? We're good? All right, let's hit stop record.